So before we start, I would quickly like to talk about what we have done so far in this lab. We have had about 10 weeks of labs, and then we started with the basic, right? Lab 1, we talk about Python. Basically, we introduce ourselves to Python, and then Google Colab, and how to connect your Colab to Google Drive. That was basically the content of Lab 1, and then we look at basically the important Python techniques, like functions, like NumPy array and all of that, right? And then for Lab 2, we started with linear regression, right? Linear regression, simple linear regression, basically in Python. And then we will work with advertising data set for Lab 2. So you can check your manuals. That's the content of Lab 2. And then for Lab 3, we I think we discuss multiple linear regression in Lab 3. Then we use what's advertising data set. I think we use advertising data set for Lab 3. And for Lab 4, we implement naive-based classifier and then linear discriminant analysis in Python for Lab 4, right? And then we move on to Lab 5, which is the principal component analysis and then single value decomposition, where we use it to we call it dimension reduction techniques. And then the following week, we'll talk about so many, I think, then we talk about, K-nearest neighbor and then support vector machine for classification and for regression. So we use K-nearest neighbor on iris data sets, and then we use support vector machines also on Titanic data sets, and I think advertisement data set also. Okay, so then the next lab, we talk about decision trees. Yes, we implement decision trees for regression and for classification problem, right? Then for the regression part, we use decision trees for eta data sets, and then for the classification part, we use decision tree for I think Titanic data set, right? So this is Lab 8, right, where we talk about decision trees for regression and for classification data set, right? And then the following week, which is like last week, we talk about assemble models, right? Because from the knowledge of decision trees, we advance to assemble models, which is like the assembling of more than one machine learning model, right, or more than one machine learning algorithms. And basically, we talk about we look at bagging, we look at random forest, and we look at boosting. And then this is the what's it called, the notebook for the week, which is last week. We look at bagging, we look at random forest, and we look at boosting. And for the bagging, the classification problem part, we look at Titanic data sets. And then for the random forest, for the regression problem part, we look at ITA data sets. And for the boosting, for classification, we look at Titanic data set also. And for the regression part for boosting, we look at advertisement. Actually, I asked you guys to do advertisement for the gradient boosting part. Okay, So this is what we have been doing for the past 9 weeks. Then this is the last week for this semester. I mean, for this lab, for this class. So what we are going to do is the unsupervised machine learning models. All these things they have done in the past 9 weeks, they are called supervised machine learning. They are under supervised machine learning. And what is the distinction between the supervised and the unsupervised machine learning model? It's majorly difference in the data set or the problem. For the supervised machine learning model, let me see if I can use my whiteboard. Actually, the pen I have here, I'm having issues with the calibration. I don't know, but I'm still not getting. So okay, but I'll try to. Okay, I need to move this thing to. Let me just continue. There's no need. Okay, so basically, for the supervised machine learning models, let's see if I can use this. Okay, so for the supervised machine learning models, you can see we have the input and we have the target, right? We have the target that we want to train our data set on. Like for instance, let me show you. For this Titanic data set, right? We have the input here, the passenger class, the sex, the age, this SIBSP, the other many input basically, and importantly, we have the target column, which is the survive, right? And then you remember that we have to, put this data set into input and target, which is the X and the Y, and we have it here. X is this, and the Y is this. This is a supervised machine learning model. Supervised in the sense that we are training the inputs for each available target, right? We have the target with which we use to train our data set. So we have the target with which we use to train our machine learning model. So our machine learning model is giving us prediction or classification based on that target that we use to train it, right? So this is supervised, and you remember supervised can be either regression or classification. So the point is that we have the target available. But in situations where we don't have the target, there are times that you really don't have the target. You just have the data, you just collected the data from different sources or from a single source, right? And the format of the data does not allow you to, collect the target with it. So you still want to make some decisions with the data set you have. So in this case, we cannot use any of the supervised learning models. We have to use unsupervised learning models. Let me give you an instance. Like what's it called? When you go into YouTube use some very powerful algorithm that is based on supervised learning model. How does it work? The way YouTube works, you can see that it's almost impossible that you go to YouTube and you check like the first page in YouTube and you don't find one or two videos that you are interested in. In fact, these days, when I go to YouTube to check something, I have the intention of I want to check one video. But the moment I land on YouTube like this, I almost forget why I get to YouTube, because I see some other videos that are always interested to me. So how does this thing work? The way it works is that YouTube collects your activities on YouTube. So for instance, let's say you just open YouTube account and then you go into YouTube. The first thing you watch is okay, like I'm a Chelsea fan, right? So when I go to YouTube, almost every day or almost after every Chelsea match, I watch the highlight. Even after I watch the match, I still watch the highlight. So I watch the highlight of Chelsea, and then some other things I watch, like maybe I see some music videos of my favorite artists and all of that. So what YouTube does is that I see Chelsea videos. It collects that as a data for me that I see Chelsea video. You see, when somebody else, another person see similar Chelsea video, it puts that person as, I mean, my own video, my own, what's it called, data, and the person's data as a cluster. That, okay, you watch this person also see this video. So it is a cluster. It put them in a cluster that, okay, you people, I think you have the same interest. You are in a cluster of, this particular group. So when next I enter YouTube, it comes up with that, some videos that are in that cluster, but they have not seen. For instance, maybe Chelsea have played and I don't know. And some people that are in my cluster have seen the videos. That's how it could recommend the video to me that, okay, people in the same cluster with you, they see this video also. Maybe perhaps you might be interested. And this is how, psychologically it is. So that's why most of the time when you go to YouTube, just see videos that, oh, I want to see this. They recommend some very interesting videos to you because they are working on your activities, your data you have provided for them from your previous activities, and look at how does it fall into clusters with other users. And then these days now, I think they're even putting it that people that watch these videos also watch this. So just for you to know that, okay, since you watch this, I think you also interested. So basically that is like unsupervised machine learning model based on, data set without target. They just collect my data set. I didn't tell them that, yeah, I like this, or maybe they should classify it like this. So that's the same thing we want to use and we want to do in this lab, the final lab for this semester. So for clustering, we actually have two clustering, we have some clustering machine learning models like K-means clustering and then the hierarchical clustering. So basically in this lab, we want to implement K-means and hierarchical clustering methods in Python. So for K-means, we look at two examples. The first example is just get some data, we imputed ourselves, and then we do the clustering. And for the second example, we are going to work on Iris dataset, right? Remember Iris dataset that we have been working on, it has inputs, right? Like the beta length, separ length, and then it has targets, right? The targets are the what's it called? The classes of the iris plant or flower. Is it? We're going to look at it. We have about 3 classes, I think. Iris itosa, iris something, iris something. But in this problem, we will not consider the class. We're going to see if we can work on the inputs without the class, without the target, in order to group the iris data set into some classes without the target, right? Then we want to look at the elbow, right? How do we get the best cluster or the best classes to put our data set? And then we're going to move on to hierarchical clustering, where we are going to look at basically what's the use of hierarchy in unsupervised machine learning model. How do we use dendrogram and how does it work, right? We're going to look at dendrograms. So basically, we're basically looking at the use of agglomerative clustering and then dendrograms, right? So that is what we have to do very quickly for this lab, and then I think in the next couple of minutes we should be done. Okay, let's start with the first. So for this, as usual, we have to import the matplotlib. Then for plotting, right, we import the numpy, and then we import, now here, we import K-means. And the K-means is, since we are working on unsupervised learning, it's actually cluster. It's inside cluster module of sklearn. So sklearn.cluster import K-means, right? So here, what we do basically here is that we impute some data, like just like have some array of data. So we call NP array, and then we pass in the data 5.1, 3.5. So this is like 2 columns, right? 2 columns, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 columns and 10 rows. So we have 10 by 2 data set here, 10 rows by 2 columns for X. So then we are not going to have our Y, right? Because we are working on unsupervised. Okay. Then we have this label. Actually, I don't want you guys to get confused with what this label is. This label is basically not a target. It's not the Y. It's just like label for this point. So you just have to have label for it, but the label is not the same as the Y, right? So let's look at the plots for the data. So to plot the data, we want to do scatter plot. And when you want to do scatter with matplotlib, the basic input is the X and the Y, right? You put the X and the Y. But in this case, we don't have the X and the Y. So what we want to do is just put we want to plot the first column against the second column, 3.5 and all of that. So you have 5.1 against 3.5. So this one is going to be the X, and this one is going to be like the Y axis, but they are still X, right? This one is going to be the X, and this is going to be the Y also. So that's what we do here. We plot the data, and then here, what we are doing here, we want to label the data. But before that, let me just uncomment this and then show you what we have for this one line here. Okay, so this is our plot, right? You can see, I hope you guys know how we subset this out. We just call all the rows and then the 0 column. 0 column means this first column. So you can see now, so like the first point, 5.1 by 3.5. So you can check here, 5.1 by 3.5. I think it's here. This is 5.1 and this is 3.5. So basically we have 5. Okay, the last, which one is this? 5.4 and then 3.9. So let's look at that. 5.4 and 3. I think this is 5.4 and 3.9. Okay, so basically we have all the 10 points. So that's what we are doing basically. So now what these other lines, these 2 lines of code are doing is basically to label the points. So that's why we call for label. Remember, we have label now to be 1, 0, 1 to what's it called? To 10, right? Let me try to show you list labels to put it in a list. Okay, you can see we have 1, 2, 3, 4. To 10, 1 to 10, right? So now, what we want to do basically is that we just zip the labels and the first column, the X1 and the X2, meaning that for label for 1, right, in this label, combine it with this 5.1 and 3.5. So that means this 5.1 and 3.5, we are going to put 1 there. It is not the Y, actually, it's the label. We just label this one 1, we label this one 2, and we label this one 3. So that's what this one is saying. And now, after that, we are now going to annotate our plot. So annotate is like to label it. So we annotate, meaning that we put it the label 1. And then for our XY is going to be the X and the Y. So let me just run that again and show you what we change in this plot. It's still the same plot, but just look at the change. So the change basically is just that we now have label for the points, right? 1 for the first point, and then this one extreme here is 6, and then the last one is 10, which is you can see 4.9 and then 3.1 from the plot, and you can confirm here 4.9 and 3.1. Okay, so basically we have just plotted our data. Now, how do we put this data into classes? How can we classify this data? We don't have the label for it, but then we still want to be able to put it in classes. So what we can do is we can use the unsupervised machine learning model, the K-means. So what K-means basically is doing is that you can see it's just like cluster. From the word cluster, it's just going to look at the distribution of your data set and then going to put it in different clusters. From here, you can see that this one is extremely out of the others. So if I want to put this in clusters, right, I'll just like, okay, what are the clusters? Maybe I can put this one in 2, this 2 and 10, they are similar, just put it in one class. This and this, put it in one class. This one, put it in one class, and this one, put it in one class. So in that case, I put it in like 1, 2, 3, 4, 5. I have 5 classes. But then maybe I don't want 5 classes. Maybe I just want 2 classes. So that's what we are doing. We want to apply K-means to X with K equals to 2. So the K there is the number of class. So that's why we call K-means, right, which is a model. And one of the parameters for K-means is the number of clusters that we want. So we pass 2 there, meaning that we want it to put this data set into 2 clusters. So how do you think it is going to put this thing into 2 clusters? Well, to me, I think perhaps it can just like put this one. Actually, what it does is just like, like the K nearest neighbor. You just look at the distributions and the closeness of the data set. So maybe this one to me looks like one class, and this one look like another class. Okay, so then we fit our data on our, we fit our model on our. So I'm going to run that. So we have our K-means here. So before we proceed, let me K-means second line. Just show you the documentation of K-means in case you want to look at some other parameters you can pass. So if you call K-means, this is the second line documentation. If you call K-means, by default, the number of clusters is going to be 8. In our case, where we have just 10 data points, it doesn't make sense to put it in 8 classes or 8 clusters. So you have to change this one. But if you don't, that means you are taking the default. So then the init method by default is K-means plus plus plus. You have some other ones like random, ND-array, callable, and all of that. You can look at which one is going to work best for you. And then the n init is 10 by default. The maximum iteration is 300, and some other things here. So you have some parameters here, but basically, most cases you want to just change this cluster, and then perhaps you really just don't want to be doing trial by error. You can use maybe one of these hyperparameter tuning method to get you the best parameter. Okay, so attribute. What are the attributes? The attribute for this is going to have some cluster centers, because you're going to put your data set into clusters. So it is going to give you the center for those clusters, and then the shape is going to be clusters by number of features. And you're going to have like labels for your data set, like the labels for like if you have 3 clusters, you're basically going to have the labels of 3. Then you have the inertia, which is like the sum of the square distance of samples, and you have this n iter, the number of iterations. Okay. So in this case, we have 2 clusters. We have created a machine learning model to put our data set into 2 clusters. So let's look at what is happening here. First, one of the things we can check is the cluster centers. Let's check the cluster center. So because we have two clusters, right? So we are going to have 2 rows now, which is for the 2 clusters. So what's happening there is just going to have 1 cluster here and 1 cluster here, and then we are going to have the center. So it's going to have like 1, 2. So that's why we have this. And then we can now plot the scatter diagram for our labels and for our centroid. So what are we doing basically is that, again, we are plotting our data set, but now that's why you have PLT scatter. this. It's still the same plot. Look at this and compare it with this. They are still the same plot, but the difference now between this line, look at this line, we have two parameters here, right? We have two parameters, which is the x1 and the x2. Now here we have three parameters, x1, the x2, and the k-means labels. Now this k-means label is just what's it called, a symbology terms. If you look at C here, let me show you. If you look at the scatter plot, plt dot scatter, I want to look at the scatter documentation. You have the x, which is going to be on the x-axis, the y-axis, and look at this C. For normally it is none. But if you look at the you can see the C is like the marker colors, right? So what this C is doing basically here is, where is that C now? Is to have our labels, because for this what's it called, for these clusters, it has label now. It has label each of, because we have created two clusters. So for each of the clusters, we now have label for it. So this is what I mean. Let me just use let me just use paint to show you what I mean. I'm just going to expand this. Okay, so now when we have our data set here, we have one here, we have one here, one here, one here, one here, one. This is like 1, 2, 3, and then we have 1. So what this one is doing basically is that it is now, we have two clusters now, for two clusters, 2K. So this one is just like using maybe one cluster here and the second cluster here. Okay, now what is the label? What is now the where is this so what is the label in this case? This this attribute. Remember I showed you this k-means label, labels of each point. You know, when we call labels underscore, it means we are doing the labels of each point. So that is going to say that this one can be labeled, I think it starts from 0, yes. So all these points now, remember normally what is the, I want to show you something again. You know, we have our labels now. This is our default label. But after the k-means, we have it in two clusters. Now we are going to have our clustering label. So our clustering label is going to be just this one. Is going to be 1, 1, 1, 1, 1. And for this one, it's going to be all these points, they are going to be 2, 2, 2, 2, 2, 2, right? So now we have 1, 2, 3, 4, 5, 6, you know, 2, 6, and then maybe 4 1s, okay? That's what we are doing. Okay, now when we now find our k-means, now we want to, where is the plot we are doing? Okay, so basically what we are doing here is that we just, you know, symbolize this one based on their labels. So similar labels, we have the same symbol, and then we have the plot, and then we have the normal label for 1, 2, 3, and all of that. Okay, let me just run this and show you what we mean. Okay, you see what we mean now. This is still our data set, but this is now the clusters. These 6, 1, 5, 8, they are one cluster, and this other one, they are another cluster. So they have the same cluster as the same color, and then we now see the distribution of our data. So this is what k-means clustering is doing. We can find the labels, right? So start from 0 actually. So we have 0 for the first point, and 1, 1, 1 for the next 3 points, which is 2, 3, 4, and the 5th point is 0, the 6 is 0, and then the 7 is 1, the 8 is 0, and then the 9, 10, they have 1, class 1. So this is how you use K-means clustering for unsupervised machine learning model. So before I proceed, I want to ask if you have any questions before we move on, because we're just going to quickly rush through the remaining task. So any questions from you guys?
No, sir. So far, okay.
Okay, good. Okay, so we are going to look at K-means clustering for another example here, which is the iris dataset we have been working with in the past classes. So what we do here basically is to import the pandas, and then before that I need to load my dataset. Where is the data? I think it's not here. So iris dataset, I'm going to load it there. Okay, we have it. So I can now read my data. So you can see you have the sepal length and then the Y column. But what we want to do now is we want to put our inputs, take our inputs, because we are dropping this species, we are not using this species here because we want to use unsupervised approach now. So here we call this Y basically. It's not the Y that we are used to in the supervised learning. It's just like X actually, but we call it Y. You can change it to maybe X to avoid confusion. Okay, so we have the sepal length, the sepal width, the petal length, and the petal width. And then we can look at our data set now. So you can see this is basically our data set. So what we want to do is we just call the K-means clustering, we find the number of clusters, right? To be, we chose 3 to be the number of clusters, and then we fit it on the data set. Then we want to plug in, we want to print our clusters, our cluster centers. So we have 3 classes, right? Or we have 3 clusters. So we have 3 we have 3 rows here. And for each of the cluster center is going to have the corresponding, because just like you want to plot this thing now, right? Just like this one now. We have, let's say this is our cluster for this. This is our cluster center rather. For this one now, this is our cluster center. And then for this one, this is our. So what it means is that because we have, for here, we have 2 features. So this cluster center is going to have corresponding coordinate of the, for each features. That's going to have coordinate for this one. It's going to have coordinate for this one also. And also this one too. It's going to have coordinate for this, and going to have coordinate for this. But in a situation where we have 4 features, that means in addition to the 2 coordinate, it's going to have coordinate for the other 2 features also. So that's why you have these cluster centers to have 4 columns, because here we have 4 inputs. So, but then we have 3 clusters. So that's why we have this one to be what's it called? 3 rows by 4 columns, and this is the cluster centers. So let's plot our this thing, plot this. So to plot this, we've just plot the first input column and the second column of our input. So we just take all the Y. We use ilog now. We take this Y, right? We take all the columns, and we take all the rows and the first column. That means this sepal length. Basically, we are plotting the sepal length and then the sepal width and then we are labeling based on the clusters. Okay, let's look at that. You can see this is how it put it into different labels. So we have, different clusters. So you have the first cluster here, the second one here, and the third one here. So what we can do also is we can plot the cluster centers. So just to plot it, just plot this one, K-means cluster centers, the first against this. So when we make it to be red, you can see. So we have the first one, the second, and the third here. So this is the different clusters that we put our listing. We can use the other, let's see how the other two columns also perform. This is going to be 2 and this is going to be 2, and this is going to be 3, and then this is going to be 2, 8. Okay, so you see, this is how you put it in clusters. For these 2 something, you have the clusters to be here basically. So this is how you use what's it called, the K-means to cluster your points into different, to cluster your data set into different classes. So they're actually simple, and then they are only used when you still want to work on the data set and you don't have targets for. So this is so far what we can do with K-means clustering. Okay, so another thing, let's look at the sections. Another thing we have is that we want to determine the best cluster to put our data set, right? Let me change this one back. So 1, and then I think. Okay, another thing we want, like I'm saying, another thing we want to do is determine the best clusters to put our data set. Why is this thing important? It's because, like this one now, if I decide to put this thing into, now I chose 3 clusters because I know that this data set should, be in 3 clusters. And how do I know that? It's because I am used to the data set with the labels. I know the labels basically before. The target, I know that there are 3 clusters, right? Like Setosa and the Virginica, and then there's another one between it or something. So I know that there are 3 clusters, or there are 3 classes for this data set. But in situation where we really don't know the number of classes, how do we put this thing into the relevant or the required number of classes? Because I can make this one to be 10 classes, and then it's still going to put it in clusters. But then it might not be a kind of important or the required clusters for my data set. So it's always good to check for the number of K that we want to determine. So to do that, one of the methods to do is using elbow method. You see, elbow method, what it does is, let's look at this. It helps to determine the optimal number of clusters, right? It consists in plotting the distortions as a function of the number of cluster K. Then it selects the value of K at the elbow. So it's going to select the value of K. When you plot it, there is a plot that is going to give you how each of the clusters is giving the distortions for the data set. Okay, this is what this elbow is doing. So what you are doing is you want to select K such that your distortion is minimal or not too minimal. Let me show you what I mean. Now let's assume that I'm going to remove the center that I put for this. Let's assume that instead of 2 clusters that I put these 10 data points, for each of these clusters now, the distortion, when we are talking about distortions, D for D1, it has two distortions, but because we have what's it called, two clusters. So it's going to look at this center now. What is the distance? How far does each of these points differ from the center? So it's going to find the sum of all of these things and put it in a sum. So we have sum of square error for this one, and for D2, we are going to have sum of squares error for D2. We have SSE2. So my distortion for K2, which is when K is 2, is going to be the sum of all of this. And you are going to know that for this K equals to 2, the distortion is going to be large. Now, if I decide to make my cluster to be 3 now, right? I make my cluster to be 3. That means I'm going to have another, let's say, instead of having 2 clusters here, I have, let's say, another cluster here. This one now is now another cluster. Now, that means you can see that this one, this yellow now, is going to be like this. It's going to be like this now. And now the distortion for this one, because the center is now going to change. Now, the new center for this one is going to be this. The distortion for this yellow is going to be reduced. Then the distortion for this purple is also going to be minimal. Then also this one, maybe this one can remain the same because it's still the same. But the point is that when I make my K to be equals to 3 now, when my K equals to 3, my distortion is reduced, is minimal. My distortion is minimal. So the point is, for each of the clusters, the distortion is going to be reduced. For each increase in number of clusters, there's going to be reduction for each increase in the number of clusters, there is going to be reduction in the distortions of the model. So what we want to do is we want to select a K that has minimal distortion, but not too small distortions. Why not too small? Because by the time we put this thing in, let's say we now put it in like 10 clusters now, and we have like 10 points, and we put it in 10 clusters. What it's doing basically is just to put each of the points in different classes. 1, 2, 3, 4, 5, and then the distortion in this case is going to be very small distortion. But we don't want very small distortions. We don't want it to put it in 10 classes. In that case, where we are going to have very small distortions, we just want small distortions, but not too small distortions. So what it means is that we can plot our K now against our distortions, right? So when our K is 2, this our distortion is I. When our K is 3, our distortion is reduced. When our K is 4, our distortion is reduced. When our K is now going to 5, it is now going to be small and small and small and small and small. So what we can do is our best K is where this, if you look at this thing now, you can join this one. Oh my. You can join this one now with, let's say, a line, and then you can see that at a point, it starts getting so reduced. Now, K elbow is saying that your best cluster is at this point that it looks like K. You know, it is reducing on a linear scale or on a linear format until it started, reducing so minimally. So we want that reduction where it is reducing. But now when it gets reducing at a very, very small value, we want to ignore those parts. So that is what K elbow is doing. So here you can see, if you read this, then select the value of K at the elbow, which is the value of K after which the distortion starts decreasing in a linear fashion. So that's what we are doing. Okay. So to do that, let's look at how we can determine the best K for this first example. Right? What we are doing is we are assuming that we don't know the number of K to put here. So we want to use elbow method, basically. So what we do is, let's create an empty list of the distortion, And now we want to calculate the distortions for each k from 1 to 10. So we say k equals to range 1 to 10 because we want to try for different value of k's. Then for k in this k, our model, K-mean model equals to this K-means. The number of k is now, the number of cluster is now k. That means for 1, we have cluster 1. For k equals to 2, we have cluster 2. And up to for k equals to 9, we have cluster 9. So we now fitting each of the K-means for the different k values on our data set Y. Then we find the distortions, which is the k model on the dot inertia underscore. If you look at this, inertia, it is the sum of squares of the distance of the samples to their closest cluster center. Okay, so that is doing the distortion. Okay, so we are appending the distortion for each of the k into this list. That means we have the 9 distortions there. So let's run that. I think I don't run the distortions. Yeah, I didn't run this. So let's do this. Now we can find our distortions now. So you can see our distortions. So when our k is 1, this is for k equals to 1, our distortion is so large, 680. When our k is 2, our distortion is large, get reduced compared to the first. Now our k is 3, our distortion gets reduced. The point is our distortion will keep on getting reduced. But we want to select k such that, it is minimal, not the highest, and not one of the least. So it should be something around this, So that's the essence of the k. So let's plot this curve. From here, we can see that it should be maybe 57 or 46. Any of these two will be fine. But this one will be too much. That means we are putting in 9 classes. So the distortion is very minimal. Here, this is just one class. So it should be here, basically, or here. So when we plot this, the k against the distortions, we can find this, we title it elbow. So we look at how that, so this is it. When k is 1, you have this. When k is 2, you have this. So basically, if you choose 2, you are still fine. And then if you choose 3 also, you can see you are still fine. If you choose 4, I can still choose 4 and still be okay. But anything from 4 like this, it is getting some 2 small distortions that is not going to make sense if you put your classes into the different clusters. So here you can choose your k to be 3, and then now when you now want to do your number of clusters, you just put n to be n clusters. Now it's not going to be 3. So this is the elbow something to determine the best number of k for your clusters. Okay, so before we move to the hierarchical clustering, I would like to pause here and then ask for questions if you have any. But if you don't, we continue with the class. Do you have any questions before we proceed?
No, sir.
Okay, good. Okay, so we'll move on. Okay, so now let's quickly talk about the hierarchical clustering approach. So basically, hierarchical is still trying to do the same thing as K-means, but the approach is a little bit different from K-means. Remember, in K-means, we are looking at the clustering of the point, and then we are putting it based on their distribution. In hierarchical, what it is doing is that the way hierarchical works is that it is putting it in hierarchy. You have hierarchy of points based on their features, basically. So what that means is that it can be like the hierarchy can be from the top to bottom, or it can be from bottom up. Just like you have hierarchy of animals. What you want to do is that you want to look at it. Animals that has maybe they have so many, let's say they have 4 legs, like 4 legs, you put them 4, 4, 4, 4, 4. So that's one hierarchy. Then the ones that has 2 legs, you put them in another hierarchy, and then you can now go up. The one that have 4 legs, you can move up, like, okay, what other things can I use that will be higher hierarchy? The hierarchy can be like are they mammals or something? So you just keep on going like that. Eventually, you are going to come up to the hierarchy of classes of animals. Here you're going to have like maybe one animal is a mammal, then amphibian or a reptile, or so many classes like that. So, but then the point is, you come from the low features and you start grouping them up to, you can consider it like kind of what's it called? Like a kind of decision trees, right? Like you keep going from one point, put it in class and then another something. Okay, but this is hierarchical clustering anyways. So but a way for you to understand hierarchical clustering is dendrogram. So here we are going to plot the dendrogram for hierarchical clustering for you to understand what it's doing. But first, let's plot our data set. We are still plotting the same X data set. So nothing has changed here basically. So we just have our plots, right? Now let's look at the dendrogram for this hierarchical clustering. So to do that, we look at this. The dendrogram is inside the hierarchical module of the SciPy clusters. So we call the matplotlib, and we now create our model link equals to linkage of X. We just call linkage, and then we pass our data set. So we have our label list. Now let's plot the dendrogram now. So we just call the dendrogram, then we pass the link model, and then this is the orientation. So let's just see what that looks like. So this is the plot of our dendrogram for this data set. So what is this plot? What is this saying? I'm going to explain to you now. You see, like I told you, this one is bottom up. It is coming from the least up to the top. You can look at this. These ones, they are the points. You can see you have the 1, 2, 3, 4, 5, 6, up to 10. Now, look at the connections. I want you to look at the connections. This is one connection. This is the topmost connections. The bottom connection is the shorter, what's it called? Branch. You can call it branch. And which is this? This is the shorter branch, or the shortest actually. And this is the longest. Then after this, you have the next one here. And after this next one, you have this and this, they are almost the same. So you can make it like, okay, yeah, the same. Then the next one, it joins this one and this one, and then join this one and this one and this. Okay, let me show you what this one is doing. To do that, I'm going to just minimize my listing. I'm going to minimize this also. I'm going to put this one here. I'm not sure this is going to work. Okay, but the point is that you see, these 2 and 10, these 2 and 10, these 2 and 10, they are the closest. You can check 2 and 10. They are the closest. If you check, okay, look at this. Look at this distribution of the data set. You can see that these 2 and 10, they are the closest to one another among all the data points. So that's why the first dendrogram branch is the 2 and 10. So after the 2 and 10, it looks at the data distribution again and find out which one is the next. You can see the 1 and 5 and the 1 and 8. You can from there get inside that, okay, the next ones are the 1 and 5 and the 1 and 8. You can see that from this visualization, these are the closest after this 2 and 10. So you put them into clusters also. Then the other ones you can check is that look at these 3 and 4 next also. 3, and 4. And it keeps on putting them into branches like that and going up. Then it combines the 2 and 10 and the 3 and 4, right? Firstly, it combines this 2 and 10 with the 7. You can see this 2 and 10 and this 7. It put them into, because this is now 2 and 10 now. This is now 7. Because we have 4 and 3 already, right? We have 4 and 3. So it's going to ignore that, but then put it in branch with another close point. So let's say 4 and 3 and 7. Let's look at that. You can see 4, 3, and 7. They are very close. So eventually it has the topmost connection, which is the 6. I can see that the 6 is the farthest, right? The 6, and then all the clusters that it has made from all these points. So you just like combine the 6 and this. Okay, so this is the dendrogram. Now, if we want to have our clusters now, if we want to have one cluster, what we are going to do is just that we are just going to cut the cluster at this point, at this topmost point. Now, if we want to, that means going to just put it into, the 6 and everything. That's why we have one cluster, everything into one cluster. Now, if we want to have 2 clusters, we are going to just cut this and this at this next line. So what means is that you're going to have this 6 as one cluster, and then all these ones, right? All these 8, 1 something as another cluster, right? So then you're going to have this 6 and all of these one cluster, and all of these as another clusters, like here. Do you understand? So that's why we have in our this thing the 2 clusters that we have for this data set. I'm going to show you. Where is it? We have 6, 1, 5, 8, right? Because if you look at this dendrogram, you can see 2 clusters. We are going to do 1, 2. So cut it at here. Cut it at this point. So that means you have 1 branch here and 1 branch here. And the 1 branch here is 8, 1, 5, and 6. And the other branch here is 9, 2, 10, 7, 3, 4. You can see, where is it? Let me just maximize. 9, 2, 10, 7, 3, 4. So this is what we are doing for in dendrograms. Basically, we are just using the branches. And if you want to have 3, what is it called? 3 clusters now, you are going to cut at the next line here. The next line here. That means you are going to have for this one, and this one. So for this one, right, you are going to have 6, 8, 1, 5. For this one, you are going to have 9, 2, 10, 7. And for this one, you are going to have just 9 and all of this. And for this one, you are going to have the ones that come here like this. So this is basically dendrogram. It's just for you to see how your points are being like clusters from bottom to the top. So it's still the same principle with K-means. So that's it. That's just clustering. That's what it does. And then for the hierarchical clustering of example 2, but the problem with clustering is that, the problem with hierarchical clustering with dendrogram is that the more the features, remember we have 10 features now. That's why we have the branches going up. But if you have 100 features now, the clustering diagram is going to get so overwhelming, and then it gets so confusing. We don't really know how it moves again, and then the computational cost is going to be really high. It's going to take time to put it into different dendrograms, trees, and all of that. For instance, let's look at the example we use for this what is it called, the iris data set, right? For this iris data set where we have our y, in this case we have 150 features now, right? And then we want to now plot the dendrograms. So we put our y, and then we want to plot the figure. Let's look at what happens. Now it's trying to plot the dendrogram. You can see this is the dendrograms and this is the classification. you can see that this is getting, because it tries to plot for all the 150 points, and it's getting really, but the same principle, right? You just put it into different dendrograms starting from the bottom up, and all. But the point is that it is really confusing. It is really overwhelming. We don't know which one is the first and then which one is the last, because it's really so many features now. So, but then the point is we're still able to get the classes because we put it to be 2, number of clusters to be 2, and it's still able to do the clustering. So basically, this is how unsupervised machine learning approach works. So this is the end of this lab, and guys, basically this is going to be the end of the lab demonstration, I think. So I have requests from a couple of you guys, because I don't know what's wrong with my recording. Some of you cannot access it. They say that it's asking for. I've tried to look at the settings and then I'm unable to fix the problem anyways. So the point is that I have the videos. I can see the video from my end. So I just downloaded the videos and I put it on YouTube. In case you guys want to look at it, I'm going to add, I just quickly do that. I started doing it a couple of days back, but I uploaded the remaining like 2. They are not, it's not all the videos I'm able to get anyways. There are about 5 of them. But the point, the good thing is that the important algorithms, like the multiple linear regression, the support vector, and then the what's it called? The decision trees, the random forest, the ensemble models, basically, and then yes. So all those algorithms are very vital. I was able to put it on YouTube. So I'm going to share, in case you want to look at them, I'm going to share the link with you guys. It's on the playlist. They have, right now there are about 5 videos or thereabouts there, so you can check it out if you want to go over the algorithms again and see. So this is it. Actually, it's just I'm still going to upload the what's it called, the collab. This is this thing. So you have this here. I think the 4th one is still loading. So you can look at this, and I think I have some other playlists for machine learning and deep learning modules if you want to, immerse yourself in this thing. So you can look at this again. So I'm going to add the, what's it called, the notebook that we have been using, like all this notebook. I'm going to add them so that in case you want to look at the notebook again, all of them, I'm going to add them to the respective videos. But you have the videos there on YouTube, you can check it, and then I don't actually upload YouTube videos, but just that you guys can, what's it called? You guys can, maybe you want to check again, you can look it there. Okay, so guys, this is the end of this lab, and probably the end of this course lab demonstrations. So I think Mr. Naim is here now, and then I'm just, oh, sorry, do you guys have questions? I forgot. Do you have questions? Any question from you guys?
No, sir.
Okay, now, so then I pass the floor to Mr. Naim to take charge now. Mr. Naim. Okay, Mr. Naim is actually here but not with us. So let's just let's call it a day, guys. So it's been nice having the past 10 weeks with you guys. So guys, take care of yourself.